So I chose objectives 1 and 4 to illustrate this time. Objective 1 is a solve graph and give interval notation for basic linear inequalities and tripartite inequalities. I don't usually use the term tripartite, but the word itself means 3, right? From tri, and then partite, it's like 3 parts. So I checked tripartite means it's just like a double inequality. You have one expression, smaller or equal or smaller than another expression, which again is smaller or equal than a third expression. So you have three expressions separated by like smaller or bigger signs like between them. So that's called a tripartite inequality. And I want you to note that for all these exercises, x is not going to be raised to any power other than 1. So you're going to have x. You're never going to see x squared or x cubed or anything like that, which will complicate matters. Yeah, so it's always with just x plus something or a number times x plus another number like that. And so an example I chose was 2 minus 4x, 4 times x, yeah, 2 minus 4 times x greater or equal than minus 5 plus x. And we want to know what numbers x can take that will hold, like will make this inequality true. And so solving, it's pretty much like when we solve equations, actually, like you add stuff to both sides, you subtract stuff to both sides, you divide by a positive number on both sides. Yeah. So for example, I added 4x to both sides. So 2 minus 4x plus 4x became just 2 on the left side. And minus 5 plus x plus 4x became minus 5 plus 5x. Is that okay for everyone? Like from the...
I think what I'm misunderstanding is why we added 4x to both sides.
I'm trying to isolate x to one side and the number to the other side.
Okay, and so that's why we then did 5.
So that's why I chose 4x, because I have a negative 4x on the left that I want to cancel out. It was on purpose to cancel it out.
Okay.
So then I have
5.
Yeah, then I cancel the number. So it's basically moving all the numbers that are without the x to one side, and then all the ones that have x to the other side.
Okay.
So then I cancel the x on the left, but now I have this minus 5 on the right side, right? I have minus 5 plus 5x. So I add 5 to both sides.
Mm-hmm.
So then I get 7 greater or equal than 5x. Right? Because 2 plus 5 is 7, and then negative 5 plus 5 is 0. So now I have number 7 on one side and then 5x on the other side. And so now I can divide everybody by 5. I get 7/5 greater or equal to 5 divided by 5 times x. So that's 5 divided by 5 is 1. So I cancel. Basically, I have 7/5 greater or equal than x.
Why did we divide by 5 in the third step?
Because on the right side I have 5x. So if 5x is, smaller or equal than 7, then x is going to be smaller or equal than 7/5.
But why'd you choose to divide? Is it because 5 next to an x stands for multiplication?
Yeah. It is exactly because of that. So if it was 2x, I will have divided by 2, everybody. Because I want x, right? I basically want to solving for me means x less than or equal to something, or x greater or equal than something. So all I'm trying to do is grouping all the x to one side and throwing all the independent numbers to the other side. And then once I have isolated them, I try to divide by whatever is multiplying x, so that I get x smaller or equal than 7/5.
And is this a rule for linear inequalities that you're trying to isolate x and that you can do the same thing to both sides? Is that just for linear equalities, or is that a rule of linear equalities?
It's a rule for linear equalities and also inequalities. But there's one thing that's different for inequality, which is when you multiply by a negative number, you have to be careful.
Okay.
You have to switch the sign. So that's why I avoid multiplying by negative numbers or dividing by negative numbers, because I think I can forget to switch it. The reason why this happens is like 3 is bigger than 2, right? 3 is a bigger number than 2, but -3 is a smaller number than -2. So it kind of, when it's on the negative side, it kind of switches. So it kind of, when you multiply by a negative number, you have to remember to switch. Otherwise, it's going to mess up your inequality. But when it's an equality, you don't have to worry about anything, right? Because the two sides are the same. So then there's not a problem with that. So this is what I avoid dealing with negative number. I'm always adding and dividing by positive numbers, and you don't have so much problem. I want to show what I mean when I say switch the sign of the inequality. It's like this. What I mean is when we have something that's like this, say x greater than 5, okay? When I multiply everybody by -1, I have to remember that it doesn't hold true. I have to have negative x, and then here becomes -5, right? But because this was negative, I have to remember that this thing switches. It becomes this way. This is what I mean. And it looks pretty crazy like this. It's like, what? Why is that? But it's like, let's take like 7, right? 7 is greater than 5. But then -7 is going to be smaller than -5. Because on the negative side, the bigger the number is, the worse it is, right? It's more negative.
Okay,
So,
that makes sense now. Seeing it with a 7 in its place makes more sense.
But I don't like that, because I kind of forget to switch sometimes, and then that really messes up. Because if you forget, then you're going to end up having like something like this, right? Which is not the same. So you have to remember, when you multiply by a negative number, this sign thing, this guy here has to switch. But then you're like, hey, what if it's like less than or equal? So less than or equal, when you multiply, then it becomes greater or equal becomes less than or equal, and then less than or equal becomes greater or equal. But when it's a positive, number, then you don't need to switch anything. So, okay, so there are shortcuts, right? The way I did it, it was the slow way. If you feel comfortable, you can start doing the steps faster. You can go, like say I have 2x plus 1 greater than 0, greater or equal to 0, and I want to solve this for x. So I have 2x on this side, so I'm going to say, hey, I'm going to store this guy over here. So all what's going to happen is whenever he moves sides, he changes sign. And this guy is multiplying, so I'm going to divide everybody by 2 here. So then it becomes x greater or equal to -1 divided by 2, like that. But all I did was, instead of just going here, I told you like add -1 to both sides. So you added here, it canceled, and then this guy here had -1, right? And then I said here, divide by 2 on both sides. So then it's basically the things people say like, hey, it's multiplying here, then just switch over here and then put it on divide, right? Basically, he's doing dividing by 2 everyone and then canceling this out. But if you are afraid that you might mess it up or forget some step, then just do it one by one slowly. Make sure that every move you make is equivalent. It's okay. Like a legal move, right? You want to make sure. Yeah, is that okay?